Good evening, everyone. Thank you for joining us today. To our audience on YouTube, if you can quickly confirm if I am audible to you, you can just drop in
Good evening,
on the
everyone.
chat box.
Thank you for joining us today. To our audience on YouTube, if you can quickly
Perfect. I guess I'm audible. I just did a quick check. Once again, good evening, everyone, and thank you for joining us today for this Academy session on Formula Student Vehicle Dynamic Simulation in collaboration with MathWorks. This session will be delivered by Veer Alakshendra, Manager of Education Programs, Teams at MathWorks. Without further ado, I would like to hand over the session to Veer.
Perfect. I'll just do one check. Rita, am I audible?
Yes, you are, Veer.
Okay, perfect. Okay, yeah, thanks for the glitch. I mean, sorry for the glitch. I think I played the YouTube as well. So yeah, hi everyone, and welcome to the session on Formula One Vehicle Dynamic Simulation. As Rindita mentioned, my name is Veer Alakshindr, and I manage the education programs team in India, and I also lead multiple Formula student competitions worldwide, where I'm helping students to use MathWorks tools for the competition, and including other automotive competitions as well. So this is a some one topic that we always do. Last year also we did on the Formula Bharat YouTube live session, and also on other platforms all as well, like other Formula student competitions that we are supporting. But every time there's something new, we want to bring something new and some latest updates. And at the same time, you may not be present last time, so it will be a good that you have the understanding that what are the resources that we have now. So again, last year, and I think we last year and even this year, we sort of like worked on multiple models, tried to update it, and got some more features into these models and different codes. So we thought again, let's go ahead with the same topic with some added features. So what we'll do is in this session, we'll start with tire modeling. I remember we did one more session last time, but this time I would say based on the feedback that we received from multiple students, multiple teams, that they need specifically the solution around the TTC tire data that they have. So we have it now. So we'll be walking it through. Okay, what's the process and what are different toolboxes that we are using and what is the steps that we are following. So this time we have tested the script in collaboration with some of the teams also worked with us and tested their TTC tire data to see how the fit comes and how it can be further exported into the .eif format, which is relevant for vehicle dynamic simulations. And then further, we'll go into full vehicle simulation, specifically around vehicle dynamics. So we'll talk about vehicle dynamics block set, and further we'll go deeper into the Simscape multi-body Formula One vehicle car model. Okay, so let's get started. And the question is like, what's new that we are going to solve in the tire modeling? Okay, this is something that a lot of teams have done. They have their own code. It can be in MATLAB, it can be in some different other software, and they might have some apps or they have a script around it. So there are different process, and or they are using some different toolboxes. But even though there's these question, I mean, you have already done it or in a process to do it, so we still see a lot of questions around it in the past 1 year or past few months. Basically, the question is again the tire modeling, different tire models, fitting or even converting it into .tir formats. So that's why we are here. We came up last few months. We have been working with multiple teams, and we came up with this script, which will be following this process that generally all the team follows. So we'll take the tire data that we have. So it will be a TTC tire data format. So we don't have a TTC tire data with us. We generally like have kind of, I would say, synthetic data, but the format is almost the same. And we have tested with other teams, so it definitely works. So we'll import that tire data, which is in the .mat file, and then we'll pre-process it and then visualize it. And then further, we'll fit the tire data and export it into certain format, which can be helpful for the vehicle dynamic simulation. Okay. So what we are going to do after that is basically we'll see that how these tire models can be further used in vehicle dynamic simulation, along with even other things like suspension systems and all. Like we'll like touch base on that as well. So here's the agenda. Tire modeling and Simscape Formula Student Vehicle Model we'll be going through, and then we can open for questions. But I'll take a pause after completing this section, tire modeling, to see if there are any questions, and then we can go to the next topic, that is Simscape Formula Student Vehicle Model. Okay, so the tire modeling is basically an add-on to the vehicle dynamics block set. Just to give an overview, what does vehicle dynamics block set does is basically you can model and simulate vehicle dynamics in 3D virtual environment. So we have multiple blocks which you can directly use, or you can use certain reference applications or examples. Those are already there. Okay, so you can leverage any of these. So we have enough blocks which are there and enough examples, and along with the visualization in Unreal Engine. So we'll see an example around it, but just wanted to give an overview sort of thing that what this product contains, because the tire object, or I would say the tire feature that we are going to talk about, is an extension to this vehicle dynamics block set. Now, going ahead, so the tool or the add-on that we are going to use is called Extended Tire Features for Vehicle Dynamics Block Set. So it provides a set of tools to work with tire data and integrate tire models into vehicle simulations. Okay. So basically it's an add-on. So when you open MATLAB, you need to go and click on the add-on and search for extended tire feature for vehicle dynamics block set. I'll show you the step. Okay. And then what it contains is basically is that it has multiple built-in functions which are already there. For example, if I categorize into two sections, one is the tire data and another is a tire model. So tire data contains coordinate system transform, crop, data import, which is the tire data import, which is the most important thing. And then it has some other functions, built-in functions as well, like split, struct, mean, filter. All these functions are also there. Now, once that is done, the next task is basically that you want to model the tire. So in that case, you can define a tire model, or then further you can export it. In many cases, some tire data is also missing. I think in the TTC as well, there are some tire data for specific tires which are missing. So that also you can try to estimate using certain functions which are there. Okay. So what we'll do is we'll follow this demo following this workflow, that is import, preprocess, visualize, fit model, and export to the Simulink model. Okay, so now we'll switch to MATLAB and check out the example that we have that is completely a tire fitting and export for a TTC tire data. But again, the TTC tire data is basically that we have is more of a synthetic tire data that we have. Okay, so what you need to do is initially, let me just clear my screen. There's a tab that is coming for sharing. Okay, yeah. So when you go to add-on over here, uh, you go to add-on over here, and this will open up. And then first you need to install the extended tire feature that we have. Okay, so okay, over here, and then you just type extended tire feature. So once you click on this, okay, you can just click on install. Since I've already installed, it is showing me manage. Okay, so once you install it, it hardly takes 1 minute. You can just sort of install it, and then you will be all set. If you don't install it and you try to run the script that we are showing, it will throw error that the function is not found. Okay. So with that, so once assuming that you have installed, let's take the first example. So in the first example, what we are going to do is basically a cornering data. It is, I mean, just having the lateral data that you have. Okay. So this is the data that we have, basically FSJ, I've just named it lateral data that we have over here. Okay, sorry, this one, yeah, the tire data, lat. Okay, so this has the data in the same format that you get it from TTC. And then what we have done is we have written a script around that. Okay. Now let's go through these steps. I'm not going to run this currently, but I already have, I mean, run this and you have the fitting and all, everything is ready. So this script basically contains a link to install the support package. So install the add-on, then also link to list of functions. Okay, and there's also a link to getting started with extended tire feature. Okay, so in this session, basically, I'm talking about how we have utilized this extended tire feature for fitting the tire data, TTC tire data. However, if you are doing some other automotive projects, where you where you have data in different formats. Okay, so that also we support. So you can have a look into this and then we can further just, I mean, there are many examples which can use for further of your projects like fitting data or exporting to different tire formats. Okay, so I've also mentioned that how to use this script. Okay, so the first step that we do, we load the tire data, lateral tire data over here. Okay. So once we have loaded lateral tire data, the next task is basically the tire, creating an empty tire object. So basically the whole extended tire feature, what it is based on is basically creating a tire object. Okay, you should, once you have the tire object, then you can directly use the built-in functions that we have. And then using these built-in functions, okay, you can fit data, visualize, or you can define a tire model, all these actions you can take. Now, what we are doing is over here, we are basically creating an empty tire object. Okay, so we are not directly importing it using certain functions, but we are creating empty tire data object because, like in that case, we have a much better control. Okay, so this is the empty tire data object that we have created. Now you can see that it has zero values. I mean, in terms of size, you can see it has nothing basically currently. Now, once you have done with this, okay, so what we do is, since your data is a SA coordinate transform, we just use this TD new and convert it into coordinate transform to SA. Okay. Now, let me just also open the function list, okay, which I also showed you in the PPT. So for example, like over here, you can see that in the documentation also, we have provided all the information, okay, that what all, I mean, things you can do, basically that import, generate, and all this information is over here, okay. And then the coordinate transform that I'm talking about. So again, the info about this is given over here, that how do you use this built-in function. Okay. Now, once you have done with this, okay, so now the task is basically to populate this data. So currently, as you can see that when we define a empty tire object, okay, so it has all the empty data, I would say data channels that you have. You have elapsed time, segment, measured numbers, fx, fy, fc, mz, mx, all this data is currently empty. Now the next task is basically to populate the tire object. Okay. Now once you do this, what you have to do is like you just start extracting the values from your mat file provided from the TTC tire data. So that's what we are doing. We are just extracting, because if you remember, we named this mat file as fs data. So from that, we are extracting all the values, et, and then fx, fy, mz, mx, all those values we sort of like extract. And then we further defined, I think, test facility, I think, and test machine on all this data we just defined over here. And The important thing over here is that you need to also define the which test method that it is there. So it is basically lateral. So in that, basically we have three options: lateral, longitudinal, and combined. So you need to define that. So you need to know like what kind of data it is. Okay. Once you have done that, then you can see over there, it's so easy to kind of like pre-process data. Now, what's happening is, I think those who have worked on tire modeling or those who are planning to do the tire modeling or planning to write their own script or own code, we know that there's a huge data set. Okay, so what we try to make bins of data. Okay, maybe based on elapsed time or maybe based on FZ, we make some bins. So you can see over here that split function, which is again a built-in function. Okay, we are just using this function to make some certain data bins. Okay, after that we are downsampling, just a simple command that is called downsample, and then we are just using the mean. Okay, to the entire data channel. And then further, we're just using the plot function to visualize that. So you can see over here that how we have formed, how we have the bins of data over here of different normal forces. So this is how it has created bins of data of 220 newtons, 440 newtons, and different other FC values. Okay, and this is the visualization of the data. So now what happens is even visualization of data is also important, which directly you can do it once you have created a tired object. Once it is done, once your tired object is ready, you can just use the plot command. So going back to the workspace, I can show you this, that when you create a tired object, this is what it does. It creates number of different tired objects. Okay, and then it has all this tired data that you can that you have filled in, like fx, fy, fc. All this data is over here. Okay. Now, another thing which you have added in terms of visualization, like once you have, as I was saying, that once you have created the tire data object, okay, you have, one second, yeah, okay. So once you have created that, so since it is just a lateral sweep, basically lateral data that we have currently, so it is just showing you the lateral sweep data, okay, at different inflation pressure and different inclination angles it is showing. Okay, so you can see over here that it is giving you the lateral force versus slip angle and self alignment moment. These are all can be automatically just using the plot command. You can do that. Okay, now moving back. Now the next target is basically once you have pre-processed data, then you have to visualize the data that you have done. And then now the next target is basically that you want to fit the data. Okay. Now, most of you, I think those who are a part of Formula Student Competition or working on tire modeling, they must be well aware of the fact that basically what we try to do is that, like, let's take a simplest form of magic formula. Okay, so I'm just talking about like what we generally do in the tire, fitting a tire model to tire data. What does that mean? So we have a tire model which is defined by magic formula. Okay, and then we have a data on the other side, and we just try to do sort of like a simple word, a curve fitting. Okay, just a simple layman's word, I'm just telling we just try to do a fitting over here so that we can find the coefficients. In this, currently in the simplest form, it is D, C, B, E. These are the coefficients, and we try to find the coefficients. Once you get the coefficients, it means that like and the fit is good. It means you have modeled the tire. Okay. Now this is what we are doing. Okay, but before we doing that, okay, it's important to know certain rules while using this extended tire object. Now, even these are, I would say, not exactly based on the it is coming from extended tire object, but it's basically sort of like a rule that you need to follow, an order that you need to follow when you're fitting the data. Okay. So fx pure, longitudinal data only, quite simple. You can do using the functions that we have. Then you do the f5 pure. Now, further, when you go into the combined data, okay, that you get also from the TTC tire data, then if you want have fx combined. So in that case, we have a list, as you can see over here, dependency. The dependency says that it is dependent upon fx pure and f5 pure. So basically, it means that if you're planning to do this fit, you need to make sure that first you have run the fit for fx pure and fy pure. Similarly goes for fy combined. And for example, mz pure, if you want, you need to sort of make sure that fy pure is completely done. Okay. So what does that mean in terms of the code? This is what it is, and it is quite simple to implement. So let's get into that mode. So what we are doing is, by default, we are using the tire model. Okay, we are using the tire model over here, which is again a built-in function. Okay, so what it does is basically creates a new tire model. Okay, new tire model object it is creating. Now, by default, if you don't define anything, it will take the MF 6.2 model. If you want to define, you can have MF 5.2 Dugov or Fiala. Okay, a lot of teams have seen that they work with MF 5.2, so we do have options for that as well. So as you can see, again, this is a built-in function which we have provided, which is in there. You can just use that built-in function. Okay, and then we are defining the tire model. Okay, and then after that, we are setting some dimensions. Okay, we are setting the infiltration pressure, nominal pressure, tire size, and all those things we have defined over here. And we are setting some boundary constraints. Okay, because once it starts solving, when the optimization has to converge, so if you have a better bounds, it will be like sooner converge and better converge. Okay, so once that is done, the next task is basically fitting. Now you can see over here, just to fit the lateral data, okay, which we are defining as an argument called fy pure. Okay, so what we are doing is we are just using the function which is fit. So initially we just defined the lateral data. So this is how we define the lateral data, that okay, td new, which is the basically, let me just, which was basically the populated data, the lateral data, that the tire object that has the ttc tire data. Okay, in that, what we are doing is the argument is what is a test method? It is lateral. And then we are just using fit command. And then we are doing the pure lateral fitting over here using just this command. Okay, which can be directly used. And once you do that, I can show you the fit. I think I should have it open over here. 1 second. Yeah. For example, this is the fit that you see. Okay. So that you see once you run this command. Okay, so you can have this fit perform fitting, and you can see that fitting is quite good over here. Okay, so the same thing I just showed you. So I'm not running now, it will take some time because the data set is huge, and when it starts to converge, it will take some like 5 to 6 minutes to converge. Okay, so now this is the simplest part. Then further, teams are also interested to perform the MX1 and moment, and then mz pure as well. Okay, so I think I should have the data over here. So yeah, over here you can see this is a self-alignment moment. Okay, so let me see if I have it over here. Yeah, so this is the fit for the self-alignment moment. So I can a little bit enlarge it. Okay. Some graphics issue with my laptop, but let me open that. Yeah, I mean, meanwhile it is getting back to its normal. I think should be fine now. Okay, no worries. So this is the fit that you see for the self-alignment moment. Okay, so you can see that it's not that bad. It's getting you, and then further you can, if you can refine something, like for example, this case, we are getting much better results over here. So the overall, the thing is that it's quite easy. Like once you have populated data that you have, which we have already uh, shared you in the form of a script. Okay, so in that case, over here, you can see you just need to just define your tire data, the lateral tire data. And then further, you just need to, you don't even need to do that. You might need to make some changes over here, and then some changes over here because tire size it is required. And then you can just use this command, which is already there in the script to fit the tire data. Okay. And further, then you what you get is you get this you get this whole coefficients, okay, which are there, which are required for the lateral fitting. So this all table will be also present in your workspace over here. Okay, so you can download from, or you can look into the coefficients in here as well. Okay, so what we did, we imported the tire data. I would say populated the tire data to create an object. We pre-processed the data. We created some bins, and after that, what we did, we defined the tire model based on Magic Formula 6.2. And then we defined some constraints, and then we just used the built-in fit functions which are there to fit the tire data. Okay. Now, once you're done that, many teams, they want to have the .tir format. Okay, this is a format that is widely used in industry. Okay, widely used in industries, and then also these are useful for the vehicle dynamic simulations. Okay, so of different like whichever simulation platforms you're working on. So again, for that, what you need to do is you just need to get into this export function. Again, I'll just bring that over here. Okay. So in this, we have the, okay, yes, export function. So this will export into that format that you require. Okay. So now done. Okay. Now after this, what we do is we get into the model that we have for a vehicle line simulation. So let's get into that. Okay, there's a model which does the Skidpad. Okay, I think maybe a few of you might be aware of it. So in here, what we are doing is in here, this is the this TIR form data, tire data that we extracted or exported from our tire modeling script, and we are using that. Okay. So this is the model of a Skidpad example. So this consists of Formula Student vehicle model. Okay. And this is a 7-DOF model. Okay. It doesn't have suspension now. It has 3-DOF dual track and then has simple powertrain and a tire model as well. And then it has some info around the Skidpad reference. Then it also calculates the lap time for each of the laps. And the controller is over here and the visualizations is over there. Okay. So what we're doing is that the blocks that we have in the vehicle dynamics block set. So let me get into the library now quickly. So I was talking about the vehicle dynamics block set that you already have multiple blocks which you can leverage to build your vehicle dynamics model. So this is what I was talking about. Okay, just give me a second. I think I need to stop share. Need to go on the D&D side on not the channels. Give me a second. Okay, cool. I'll reshare now. Perfect. Okay. I hope it is visible now to everyone. In case not, just put it in the chat on the YouTube. Okay. So over here, as you can see that we have the vehicle dynamics block set, and we have different sections of blocks, vehicle body, vehicle scenarios, suspension, and everything. These things are there. Okay, in that, when you go into the tire section, over here you can see all these tires are there. And these all the tire blocks are basically supporting the TIR format that we're generating from the script. Okay, so get this model ready for the use of the exported tire model. So what we need to do is we need to go into the brakes and wheels. Okay, and then in that we have the combined slip wheel 2-DOF model. Okay, in this one we just need to select the external file. Okay, there are multiple default tire type are over here, so you just need to select the external file. You select the exported .tir format. Once you do that, okay, so let me select that, and then you just update mask values from file, press OK, and then you just apply. Okay, and then done. Okay, so this is how that whole transition is basically from tire modeling to vehicle dynamics model that you see over here on the tire. Okay, now if I just click on this, let me just okay, so I'll run the simulation now. So since we are live streaming, so you might see some, I think the visualization a little bit patchy, but in like if you don't connect to the internet or sharing, it works perfectly. Okay. So yeah. So you can see over here that what we did, we are having the tire model. We have a reference examples, which is built using vehicle dynamics block set. We changed the tire parameters. Basically, what we did with the exported .tir format that we had, we just uploaded that file. It auto-populated all the coefficients in that tire block, and then it is doing the Skidpad application. Okay, perfect. So, okay. Noted. So this is how, and like this example is available. You can download, and we'll share the link as well further. Okay, so I'll stop this simulation now. Okay, now similarly, like for example, that when you are changing the vehicle, or you're planning to make a new vehicle, okay, or you want to do some comparative study. So this can be very useful because you have different tires, okay, and you have some requirements for your vehicle dynamics. So what you can do is taking this as a reference, changing the parameters, changing the different tire models, you can do some comparative studies like this. Okay. So for example, there's one model which is having a different tire. Then you have another tire model. Then you have a different that you can simulate. And then you can, to visualize that, you can use the Sim 3D blocks that we have. Okay. I'll talk more about that. Okay. Now, this is one example that I was talking about. Like, see over here that we have the simulation in place. Okay. And we are comparing the performance of two different tire models over here. Okay. So you can understand that along with the visualization, along with the data that you can have actual physics running in place, comparing two cars' performance. Okay. And at the same time, you can have a better visualization in place. Perfect. So now, talking about the visualization. So what we have done is in the vehicle dynamics block set, basically over here, if you go to vehicle scenarios, Sim 3D, for the Sim 3D core, sorry, Sim 3D vehicle, we have different blocks. So we have blocks around configuring the vehicle, configuring the scene. These blocks are the, I would say, main important blocks that will configure your vehicle over here. Okay. So in this case, what we have done, so let me just clear some of the windows. So over here, what we have done is that if you go further in the subsystem of 3D visualization, we have the Sim 3D visualization over here. Okay, so these are the two blocks. So this block is basically configuring the scene. Okay, so we are just using the default scene and we have an open surface. And then what other block is basically simulation 3D where we are using a formula student car. So we already have an asset for the formula student car. Okay, but if you want to have a custom one, then there's a procedure for that as well. Then further, to place the cone to make things more realistic as a creating a scene of your own. Okay, so what we have done is, so there's other block called simulation 3D actor. Okay, so here we are just defining the position and orientation of the cones, like how we have placed it. Okay, so you can use as it is. If you want to have a different tracks, you just need to come over here. You need to make changes and you can visualize, you can see that how the cones have been placed over here. Okay. So, before I move to the next topic, I'll just take a pause and see that if you have any questions now. Okay. So, I can see one question because I have the YouTube also open at the same time. That where will the links be posted? Posted. So we will be also. I think plan is that we will add it in the description and for the tire script. Basically, we have a form. We have a form for the tire script. If you want to request it, just fill out the form. We'll show you the QR code. You can request the form and then we can just like send you the tire script. Okay. And then for the this um, generate Skidpad test. So this is basically if you just type on Google generate Skidpad test MathWorks. This is the model. Okay, you can just copy the command and paste it in the command in the MATLAB command window, and you can run it. Okay. And also, I mean, wanted to capture one more thing is that all these models are open. You can go and customize it. If you have not kept it like a black box, you can go ahead and you can see what we have done and how we have modeled. And if you want to modify it, add suspensions, make more, more of a high fidelity model, feel free to do that. Okay, perfect. So now I'm just taking a pause, as I said, and here is the QR code if you want to test a tire script with the TTC tire data that you have. So you can just scan it. Okay, you can fill out the form, and we'll be sending you by next week the tire script. Okay. Okay. So now, now that like you have understood the whole workflow, okay. So what we'll do is now we'll take a more little bit complicated case, okay, which I think you all must be performing, okay. Uh, so now let me go to the little bit advanced script that we have, okay. Now let me just open it. Yeah. So this is one another script that we have built. Okay. So this is basically combining all different types of data, because in many applications, what you want to do is that you want to combine everything. You want to combine the lateral data, you want to combine the longitudinal data, and you want to have the combined data that you have. When I say combining, basically you want to just run one script and want to see the fitting for the lateral, longitudinal, and the combined data as well. Okay. So for that, we have prepared this whole script. So now what we are doing is almost we'll follow the same process. Okay. We'll follow the same process. And then some details we have written over here that how we have actually gone through this whole workflow. Now, few important things, what we have observed is that when we got some reference of combined data or from the teams when they were showing us online, we realized that it has two different sets of data basically. One, it does have some longitudinal test data, which is having slip angle 0. And it also has the combined slip data, which we want, okay, which is for which the slip angle is non-zero. Now, if you directly use the tire object which we are talking about, it requires some information, whether it is lateral, longitudinal, or it is combined. Okay. So now that's what we need to do. We need to split the data. So here what we are doing is we are splitting the data from this, since it is also having a portion, a small portion of longitudinal test data. So we have a initial script, okay, which we have put a simple logic on slip angle, okay, giving it a tolerance, and we have split the data and split the mat data into two, basically one longitudinal and one combined. Once we have that, once we have basically the longitudinal data and the combined data mat files, then again we are just following the same process of populating the tire object. So we start with the empty tire object, and then as you go down over here, here I have defined again how to populate the data is basically the combined data that we created after splitting and generating a mat file, the longitudinal data, and as well as I'm also uploading a lateral data. Okay. So now this is one script which will do everything, all the fitting for you. Okay. So now once you have done that, then again the same process. Now you will see additional, and I would say the use, and I would say very useful commands that can be just do this fittings in just using some fit commands. So fit fx pure we have seen. Okay, f5 pure f5 pure we have seen in the previous script. Now we are also doing fx pure, and you can see over here fx combined. Now, as you remember, if you can remember, I mentioned that you need to follow some order. The order was that if you want to perform fx combined or fi combined, you need to make sure that your fx pure and fi pure are done. Okay. Now, once that is done, then you go further. You have the self alignment mx mz pure, and all this fitting you can just do using the fit command that you have and just changing the arguments over here. Okay. Now let me show the results that we have. So it gives also in the visualization one plot, okay, which has different tool strips, and you can just toggle around it and see that how the fit you have got. Okay. So like for example, friction plot over here, combined slip, over here. Okay, you can see the for the combined slip. Okay, for the lateral force and the longitudinal slip, the fit is it's good. I mean, like over here, I mean, you can definitely kind of retune few things and you can have better results, but overall it sort of looks good. And like just to separate it out, okay, yeah, over here you can see over here the lateral force and the longitudinal slip, and the fit you can see that we have also. So this is all based on the I would say the TTC tire data, I would say synthetic TTC tire data that we have generated, and you can see the fit over here. So finally, once you have one script and you can run all together, then you can have more reliable, I would say, .tir format generated format, because it is having the lat data, longitudinal data, and also the combined data. Okay. So this is another script. So we show two scripts. One is the lateral one, and one is the data which is combining everything. One is the other script which is combining everything. Okay. Now with this, again, I'm showing the QR code. If you have, if you want to have the script with you and try with your TTC tire data, okay, we can send it once you have filled the form. Awesome. Okay. So now let's move to the next interesting part. Okay. The next part is basically the formulation Simscape multi-body model. Okay. Now, in this section, what we'll do is we'll see that how you can model a Formula Stone car using the Simscape multi-body. Now, if you're new to Simscape multi-body, what it is basically a tool in Simulink which enables you to simulate 3D mechanical systems. Okay, you can assemble bodies, joints, and you can also import CAD assemblies, or if you have STL or step files, that also you can directly import using certain blocks. Okay, so with Simscape multi-body, you can refine requirements for mechanical systems. You can discover integration issues early, because if you have the model, you can try multiple different kind of test cases. You can design control algorithms, logic, and you can also test embedded software without hardware prototypes. Okay. Now, to simplify your understanding, okay, so what I've done is I've taken a simple double wishbone suspension system, okay, simple like this, and then how we have modeled in Simscape multibody. Basically, that if you want to model, for example, this kind of modeling, if you need, first thing is that you need to have a geometry. Okay, so you need geometry for everything. Okay, where these linkages you want, or the tire, or the joints, you need some geometry which will have the dimensions, mass, inertia, and the graphics. Okay, now that can be done using the block which is there in Simscape multibody, which is called the different solid blocks that you can use. Once you have defined a body which is containing the mass, inertia, and the graphics, the next thing is that where do you place it, right? Because if you have an object with respect to some frame of reference, it could be world frame of reference, or fixed frame of reference, or it can be some moving frame of reference. How do you define that? So to define that, basically the transformation or the rotation and the translation, for that you have the block called rigid transform. And then further, once you are done, currently, once if you have this, it is static, it is not moving currently. Okay. Then to make it dynamic, or then to move it, like they need to provide a degrees of freedom. What do you need? You need another block which is called joints. Okay. So if you have an understanding of these blocks of defining the geometry, mass, inertia, and the graphics, then you have the rigid transform, and then you have understanding of how to define joints. Okay, what is different kind of joints? It's easy for you to model these systems in Simscape multibody. So again, going back to the library quickly. Okay, so again, so over here, when you come, you go to Simscape, you go to multibody, and then here you see there are different, again, buckets of blocks that we have. We have body elements, we have brick solid, cylindrical solid, but the most important one is the file solid. Why? Because the file solid helps you import some parts, like which are in different, like that you have designed in CAD software. Okay, so you can have different parts like STL, step file. Okay, and you can see over here, we have provided over here that file which you can, could be of CATIA, SolidWorks, Solid Edge. Okay, that you can import directly. Okay, similarly, if you want to design your own block of different kind of geometries, like this is one brick solid that it can be used, and similarly there are others as well. Now, once it is done, then you have, I was talking about that, how do you define the rotation and translation? For that, this is the block, this is called rigid transform. So basically, once you come over here, so you need to define the rotation. So you have different options for rotation, and then you can also define the translation. Okay, so you can have more description over here if you want. And then the most interesting part and the important part is basically joints. Okay, so there's a like a list of different joints, okay, which we have provided. Based on the degrees of freedom that you need for each of the joint, you need to use that joint. Okay, now to simplify this, let me just kind of show that, like, this is the simulation of a simple double wishbone suspension, quarter car suspension system. Okay, so this is the same model that we saw. Now, if you see over here, there are a few things. One thing is that this is the world coordinate system or fixed coordinate system. Then what we do is, how far are the hard points? So these are the hard points that we have defined. Okay, and then after that, these are the solid bodies. Okay, and this is the tire block. So now if we want to design it in Simscape multi-body, so this is how it will look like. Okay, to simplify, this is the hard points which you have defined using the combination of rigid transforms and the transformation. Then these are the joints. Okay, you have defined the joints. When you go into joints, you have different multiple options that you get. Okay, so you can define the initial position, damping, stiffness, all these things you can define. Okay, once you have done, you have the solid bodies, the upper arm and the lower arm. Basically, this is defining the geometry, mass, and inertia. And then further, it has to be connected to the upright, and for that we are using different kind of joint, which is the spherical joint and the gimbal joint. Okay, again, it depends upon the understanding of your, I mean, degrees of freedom that you require. Okay, if you are adding some joint, okay, which is not meant to solve that kinematic equation, it will break. It will throw the error that there is a constraint. Okay, or in many cases, it will also throw the error that it has some singularity. Okay, so that you have to, based on your understanding of the theory of mechanisms, you need to use these joints. Okay, so this is one example that how do you model and how do you sort of like connect one body to another and define the degrees of freedom. Okay, now further using this. Okay, so if you are new and you want to get started with this simple suspension system. These are again provided, and I'll show you the repository as well that we have. Okay, so that you can go and try it out. So start with this. Don't jump directly into the full vehicle model that I was showing in the start. Okay, so now once you have understood this, let me just give an overview of the model that we have published. Okay, so this is the Formula Student vehicle with Simscape model. Okay, this is the model that we are providing. This is available on GitHub. Okay, you can customize vehicle models. Okay, you can customize chassis, powertrain, brakes. Okay, you can post process the data that you can perform. There are multiple tools in that, and then we have also provided the suspension templates. So if you want to get started, start with the suspension templates which we have provided. Okay, now further, okay, so this is basically a lap time simulation that we have also prepared. So it is going through a Hockenheim track. Okay. Now this has also different events that we have. So for example, we have the brake test. Okay, we have the Skidpad, and we can also have acceleration. Okay, all these things are in place over here. Okay, and then I'll go through the whole repository as well, but there are different events that we have added, and you can directly use it, or if you want to create your own additional events, that can also be done. Okay, and then we have also added different kind of plot features. So this is the 2D plot. Okay, where you can select different parameters and you can plot. And then we have also added a 3D plot over here. That you can also visualize with the real car, I mean the CAD of the car that you have. And it has also options of like whether you want to see the tire forces and what other parameters that you want to see is all provided in the 3D plots. Okay. Now this model has been broken down into different subsystems. It has chassis, powertrain, brakes, controls. Okay. And these are all customizable. And then further, you can parameterize all these, and it has a decoupled suspension, it has double wishbone, it has pull rod and push rod. So let me just go around the model that we have. Okay. 1 second before I get into the customization part. So yeah, okay. So this is what the model looks like. Okay. And in terms of the files, it is a project that we have provided. So I was talking about the suspension system that you should get started with. So you need to go to the test rig. Okay, and in here we have added some quarter car and block is there. So in here you can see that different test rigs are there. Okay, so this is the old version, so that's why you don't see all the options. But we have double wishbone, pull rod, okay, decoupled suspension, which are there added in the quarter car folder. Okay, so going back to the main model over here, as you can see that this is the vehicle model. Okay, okay, this is how it has been structured. It has the chassis, okay, and then it has suspension, which I just spoke about, and then it has the body, the chassis over here. Okay, and further it has one more suspension, and then other part is basically the tire. Now you can see over here that since it is the multi-body simulation, here we are using the magic formula tire force and torque, which is meant for the Simscape multi-body simulation. Okay, so here again what we can do is we can import the tire parameters from the tire fitting that we have done. Again, there's a documentation around it. It just requires one additional step to convert that fitted tire data into the tire data that is accepted by this block. So basically, the interaction between your tire and the road surface to model that is quite easy if you use this block. Okay. So once that is done, then you can see that you can further also connect it. So I know that this is a session on vehicle dynamics, but you can see over here that we have a powertrain block. We have different options for the powertrain. Okay. And then over here, you can see that how we are using Simscape, different other blocks, electrical and thermal, to model a vehicle which is having 4 hub motors. Okay. And it also has a battery pack as well. Okay, similarly, we have a drivetrain over here. So I would say it's a full vehicle model, but you can get started with the suspension system, and then you can just have the chassis part designed for you, and then you can understand, and then further you can try having brakes subsystem, powertrain, and different wheel spins. In terms of, I was talking about different events. So it's very easy to switch between different events that we have provided over here. You have double wishbone, decoupled, pull rod, push rod. And in terms of events, you have acceleration, deceleration, Hockenheim, flat track. There are 2 tracks that we have provided, Hockenheim flat track and Hockenheim with the Z variation and even the Skidpad. Okay, so you can use or switch, just click on this and it will be configured for that. Okay, now going back to the slide. Okay, so we have also provided some more information on how to parameterize it. Okay, now how to configure. So you have different structures that you need to provide over here. Okay, so we have parameters from vehicle parameters, which is defined by vehicle chassis. Then for brake, you have vehicle dot brakes, and similarly for other powertrain parameters as well. Further, let me just go. Yeah, there are more options that we have given. I was talking about the pull rod and the decoupled one. Okay, and this is how you do the parameterization. Okay, so I was talking about the data structures. Okay, you can data structures mirrors model structure. Okay, and it contains parameter values and selected variants. So it's quite, if you want to sort of like change, so this is the structure that you need to find and need to parameterize it as per your requirements. So yeah, so this model is available on the file exchange. Okay, or even if you type on Google formulas from vehicle with Simscape, you can just find and download the latest version. Okay, and all the information, and there are different versions. So 24A, 23B. Now I think we have also updated it for the 25A and 25B. So you can try it out. And yeah, I mean, you can parameterize it. You can, so there are 2 ways of using it, and that's what we're seeing multiple teams using in different ways. There are teams, those who are just using this as a template, just changing the parameters and running around. And there are other teams that they are taking this as an inspiration and as a reference, and then using this they're building their own model, okay, their in-house model. There are multiple teams also have done that. Okay, so either ways it depends upon you how much effort you want to put in, how I mean big the team is, and what is your priority, because ultimately the priority is basically to build a car that can run and perform in the events. Okay, so you can have a look into this. But yeah, so this is what I would say we wanted to talk about. The tire modeling we discussed, we went through the vehicle dynamics block set model that we have. And then further, this is the last model that we spoke about. Okay, so now in terms of some resources, these are some resources that we have linked over here. But the most important point is that if you have any queries, you can reach out to us at racinglaunch@mathworks.com. So with this, I will end my presentation. Okay, and I'll open the stage for questions.
Thank you, Veer. We do have some questions on YouTube. Would you like to check them out, or do you want me to read
Yeah,
them for you?
yeah, I see. I don't know. I'm not able to see what. I see only one question that I don't know why my I'm not unable to scroll down. Can you help, Anita? That will be nice.
Yes, sure. Just give me a second.
Yeah.
Uh, there's a question from Gary. Could I also ask about the track layout, and if you want to build anything for a custom layout, how can
Mhm.
this be done?
So yeah, so I think I think when you asked this question, I was showing this model. Okay, so this was the model. So in this case, what you need to do is you just need to provide the reference waypoint, the XY coordinates, okay, over here, and then it can be all set. Okay, that is the waypoints. Then one other step that you will need to do is basically that when you go over here, just give me a second. When you go over the visualization one, you need to just go inside the cone section and you need to define the coordinates over here. Okay, so over here as well, basically you need to just provide the X and Y coordinates and it will be done. So for the inner loop and for the outer loop, that's how you do it. And then over here, you just need to provide the waypoints. Okay, so that way you can do it. You can have your custom. So we have tried with multiple different tracks. We have tried with FSG track. We have tried with FSUK tracks. Okay, so these two steps you do, I think then the model is set up for that track. Okay. Okay. Uh,
Thank you for
any
that,
further
Veer.
question?
There's another one. Could you please explain why the data points differ from the fitted line?
If I see, let me just over here, right? So, yeah, I mean, what I assume is that you're asking for, I would say, that why the fit is not proper. I would say the fit is still I mean, good over here. I mean, we have compared with different, I would say, data set. As you can see over here, the fit is good. You can definitely improve. I mean, I would say the fit is good for the longitudinal lateral, okay, and even for the MX, MY. Okay, some cases, for example, let me just look at this one. Okay, so in this cases also we can optimize. Okay, but we have to look into more closure into kind of like refining the I would say bounds that we have. Okay. So, but I would say like with this fit, it definitely you can go ahead with your vehicle dynamic simulation. Okay. So even the other fits that we see over here, I'm just like bringing the plots that we just plotted over here. Okay. So yeah, I would say I think the fit is good. It's yeah, maybe I think if you want, you can try different solvers that we have. But the I would say other things that you can try it out is checking the bounds that you are putting it basically we just, yeah, the nominal test condition and model limits that you want to provide. Okay, and again, like this is something like we are trying with the synthetic data, but definitely I think the fit I would say that looks good. Like yeah. Yeah, I mean, if you have the, like, as I said, that you try with your own test data, okay, if you're not convinced that the try, if it is not good, definitely I would say that reach out to us. We can help you have, I mean, better fit quality.
Thanks, Veer. There are two more questions from the same person. With
Hmm.
MF tire model versions, does this fit?
Yeah, 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 it does fit. It does fit. Yeah, yeah, it does fit. As I mentioned over here, that if I go, let me see. Okay. So we are using the MF tire model only. So tire model new. Yeah. So we are using this one basically. The 6 point, we have options for MF. We have 6.2, 5.2, Dugoff and Fiala.
Okay. Thanks for that,
Okay.
Veer. There's another one. Do you have to do any pre-filtering of tire test data to help the fitting process?
Yeah, that's a good question actually. And that's what actually what we did. We sort of here we did some pre-processing. Okay. And then in some cases, I mean, when have interacted with some of the teams, we have done some filtering. Okay. And there are some, I would say, built-in functions that let me just call it out. Where is that? Okay, easy to find in this one. Like for example, this section takes care of that actually, the pre-processing part. Okay, removing the noise, okay, that you have. Okay, so this will take care of that. Or if you want to explore some more of other functions that we have, then like I would say you can just have a look into this. But yes, we did that. We did that. Like, but at the same time, it shouldn't happen that you're filtering some important data. Okay, so that is also important that how you, I mean, how you're filtering the data. So you can also use the filter. You can see apply filter to tire data object. So this function, you can use it.
All right. Thanks, Veer. There's another question, although it's not related to FS, it's related to motorcycles. Do you want to take that question?
Yeah, I see that question. I can read it out. Now I see the question. That
Okay.
do you know something about motorcycle rider controller 2? I have texted. Okay, on LinkedIn. Okay, fine. Okay. Okay. I think what I mean, we do have some examples around that. Definitely, there are like if we go around it, let me just I can pull it up 1 second. Like currently, what we are doing in the vehicle dynamics block set, that we have provided some of the blocks, okay, and also an example that can be tried, okay, over here. So over here, this is the motorcycle body longitudinal in-plane model that we have provided. Okay, we have one example also around it, which you can have a look when you go to the vehicle dynamics block set examples. But yeah, as I said, that I would say that I'm not the expert of that. But if you have some specific requirements, you can reach out to us at the email ID that we showed. Maybe if I can find something, I would say like we can send it out to you. Okay, and then I can also see there's a question on another question on seeing the 1 second, edit the map, right? So yeah, so it is all based on like when you go inside, I hope I'm able to find that. Just give me a second. Yeah. Yeah. So this is the block. Okay, this is the block as you can see over here. This block. Okay. This one, okay. Here you need to change your basically the environment or the track for the Simscape multibody I'm talking about. Okay, so here you need to change it over here. So here you are importing the STL geometry center line and the STL geometry of the road that we are using. Okay, so as you can see, we are using this uh, uh, block 5 solid, which is importing that track. So here you can see. Okay, so that's what we have done. Okay, so this block will help you change that. Okay. I'm just yeah. Okay. Any other question?
All right. Thanks, Veer. Are we good to wrap up the session or do you want to give it a minute? with the Q&A?
Yeah, I think we are good. I saw the questions coming. I think we have answered and responded to at least all of the questions. I think we are all good. And yeah, I think since this will be available on YouTube, you can go back and rewatch. And also, if you have any queries, you can reach out to us at racinglaunch@mathworks.com. But yeah, I mean, I think I would say again, thanks and thanks to Formula Bharat giving the opportunity to present on their platform. And thanks to everyone, those who attended the session today. And thanks for the interesting questions as well. Thank you.
Thank you, Veer, and thank you to all our active. Thank you to all our active participation that we've received from the participants on YouTube, and also to Team MathWorks for hosting this session. Thank you, and have a good evening, everyone.